Okay, this is the recording for the Chapter 3 homework. Make sure this is recording here. Well, I don't see a record link here, so let's just hope it's working, and if not, I'll have to do it again. So, okay. Okay, so the reason that I really want to spend a lot of time on chapters and on homeworks early on in the book is that all of this information builds on other information, and so you really have to get these early concepts down well before you can move on to more complicated things. In my experience, I really had to practice a lot, and so that's why I'm assigning a lot of homework early on in the class. I think that it's important for us to practice a whole lot, get these concepts down so that when we move on to more difficult topics, we have the foundation upon which to build. So I'm just going to talk through the homework questions here. This was, again, Chapter 3 homework, 10, 11, 13, 14, and 15, and then 24, 25, 27, 29, 30, and 31. So I'll just go one problem at a time. For some things, I will share my screen and show you as I do things, especially if I'm building an ERD or something. Excuse me. But for other things, I will just explain them in the context of what I was looking for. Okay, so number 10. For each table in the database, identify the primary key and foreign keys. If the table does not have foreign key, write none. So we're using figure 3.10 at the top of page 109, and there's 4 different tables there. And I'll start with the job table. For the job table, you've got job code, and that's obviously the primary key. There's a unique value for each record in the table there in the job code. So that uniquely identifies a record in the table. That actually links to the employee table. In the employee table, the EMP code is the primary key that uniquely identifies each record in that table. There's a unique number for EMP code for each employee in there. However, job code is a foreign key that references the job table. And if you can see, the numbers in the job code in the employee table reference records from the job table. Okay, the plan table, plan code is the primary key. There's a unique value for each record in the database in that field. And then the benefit table is basically it captures the relationship between the employee table and the plan table. I don't know if you remember earlier on the book, it talked about the idea that when you have a many-to-many relationship between two entities, you need an associative entity between the two to basically capture that relationship, and that's what the benefit table does. So it has the primary key from the employee table, EMP code, so that's a foreign key in the benefit table. It also has the primary key from the plan table, which is plan code, which is also a foreign key in the benefit table. So it has those 2 foreign keys. Its primary key is actually a composite primary key. No one field uniquely identifies a record in here. It's the combination of both employee code and plan code that uniquely identifies a record in the benefit table. So it has a composite primary key of EMP code and plan code, and then it has 2 foreign keys, the EMP code and plan code. Okay, number 11. We need to create the ERD to show the relationship between employee and job. And for that, I will go to Lucidchart. So do screen share here. Choose my browser over here, and I'll switch to Lucidchart. Okay. So I'll go ahead and create a new document, and under categories, I don't know why these aren't really showing up. I want entity relationship diagram, ERD, and then I want to choose the blank ERD. That'll give me the correct tools to be able to use here. And for this one, I'm just relating two different entities. So I've got employee and job. So I'll go ahead and drag this one up here. I'll call it employee, and then I'll drag another entity over here, and I'll call it job. Now for the relationship between the two, I need to think about the information that's being stored in there, or the data that's being stored. So for each record in the job table, there are multiple employees that could have that job. So again, looking at the actual tables here, we've got a number one, which is the clerical job, and there are actually two employees, McDade and Ruayardo, who have that job code. So there are two employees in the actual table that have the number one job code. For each employee, each record in the employee table, there's actually only one job. So our relationship here is one to many. Okay, so that one is pretty straightforward. Okay. I will stop the screen share for a minute here. So there it is. Okay. All right, we're back. Number 13 and 14. Well, first of all, let me explain something. I skipped number 12. I didn't require that in the homework because in a relational diagram, you're required to do attributes as well. And for this part of the class, I really want to focus on entities and relationships. I don't want to spend our time typing in a whole bunch of attributes. So if I ask for an ERD, you really only need the name of the entity in there. You don't need the attributes in there. And for me, that's, one, to save you time, and two, to focus on what I think is most important right now, which is the relationships and the entities. Okay, so number 13, do the tables exhibit entity integrity? So what entity integrity means is that each entity has a primary key, and in the actual data that's in that table, they all have actual values, and each value is actually unique. So if we look at all of our tables here, they all have values for their primary keys. There's no null values in there. And all of their values are unique. So yes, they do have entity integrity. Number 14, do the tables exhibit referential integrity? Now what referential integrity means is that for foreign keys, they actually point to a record that actually exists in the table that's referenced. So if we look at the employee table, the job code is a foreign key there. So I see job codes of 2, 1, and 3 in there. So if I look over in the job table, there's 1, 2, and 3. So all those actually exist in the job table, which means it does have referential integrity. If I look at the other foreign keys, so EMP code and plan code in the benefit table, all of those reference actual records in the other tables. So yes, the answer is yes. All of the tables exhibit referential integrity. Okay, number 15. Create the ERD to show the relationships among the entities. So I'm going to go back to screen share again. Go back to Lucidchart. And I've already got 2 of the entities here. I just need to add the rest of them. So I've got job, I've got employee. I need benefit and plan. Okay. For each employee, they can have multiple benefits. For each benefit, it relates to only one employee. So one too many. For each benefit, there's only one plan. For each plan, it can have multiple benefits. So one to many. And there's our ERD. That's it for number 15. Okay. What was the next number I asked you to do? 24. Okay, so we go to the next page. On page 111, you've got figure 3.24, which has 3 of the tables, and it's continued on page 112 with 3 more tables. Those are what are going to be used for 24 through 31. So in 24, I asked you to, let me just stop the screen share for a minute here. For 24, I asked you to identify primary key, super key, candidate key, foreign key, and secondary key for each of the tables. Now for me, really the only ones that are important, the only ones I paid attention to on your homework were primary key and foreign key, because those are really the ones that we have to know, that we have to be able to do correctly to be able to move on from here. So I think it's important to understand some of those other definitions and what they mean. But for me, primary key and foreign key are the most important, and those are the ones I'm going to focus on. So I'm just going to go table by table, and I'm going to explain what the primary keys are and what the foreign keys are and what they mean here. So, all right, so in the charter table, char trip is our primary key. You'll notice that there's a unique value for each record in there, and it uniquely identifies the record. This table actually has 4 foreign keys. It has char pilot, char copilot, AC number, and cuss code. So char pilot references the pilot table. Char copilot also references the pilot table. AC number references the aircraft table, and cuss code references the customer table. Okay. The aircraft table, the AC number is the primary key. There is a foreign key, which is mod code, and that references the model table. For the model table, the mod code is the primary key. For the pilot table, EMP num is the primary key. And actually, technically speaking, EMP num is actually a foreign key as well in the pilot table. Now, I didn't necessarily count off if you got that wrong on your homework, but it's good to recognize that when you have a one-to-one relationship and one of them is a 0-to-1, which is the case in pilot. So for each employee, they're not necessarily a pilot, but for each pilot, they are an employee. You put the foreign key in the table that's 0-to-1, which is the pilot table here. Anyway, that's kind of a side note, but that would be considered a foreign key here. In the employee table, EMP num is the primary key, and in the customer table, cuss code is the primary key. No foreign keys. All right, number 25. We're going to make an ERD of all of these tables here. So I'll go back to screen share again and Lucidchart, and let's go create a new blank ERD. Okay. So when I'm doing this, when there's a lot of tables involved, I like to get the one that has all the relationships and stick it in the middle. And this would be the charter entity or table. Okay, from there I can start adding in others. So we've got aircraft. Here. We've got model. And I know model is going to relate to aircraft, so I'm going to stick it up here. I'm going to go ahead and stick customer up here. And put employee here. And put pilot right here. Now I need to start thinking about my relationships. For each model, it can have multiple aircraft. For each aircraft, it has only one model. So one to many. For each charter, there's only one aircraft on it. For each aircraft, it can fly in multiple charters. So one to many. Each customer can go on multiple charters. For each charter record, there's only one customer. One to many. Each pilot can fly on multiple charters. For each charter, there's only one pilot. One to many. Now here's a weird thing. We've actually got two fields in here that reference this table. We've got a co-pilot. So for each co-pilot, there's only one pilot. For each co-pilot, it can fly on multiple charters. So we have two one-to-many relationships, one for pilot and one for co-pilot. Okay, between employee and pilot, I explained that a while ago. It's a one-to-one, but it's kind of a funny one-to-one. So I'm going to change this one over here to one and only one, and change this one here to a 0 or 1. So each pilot is an employee, but each employee isn't necessarily a pilot. Okay. And that is number 25. All right. Number 27, it says modify this ERD to eliminate the problems created by the use of synonyms. Modify the charter table structure by eliminating char pilot and char co-pilot, then create a composite table named crew to link to the charter and employee tables. Okay. Now, and it says some crew members such as flight attendants may not be pilots. So since I'm not entering attributes in here, I don't have to delete out char pilot and char co-pilot, but I am going to delete these relationships because they're not going to exist anymore. I've got a new entity called crew. Stick it right here. And for each charter, there are multiple members of a crew. So you can have a pilot, a co-pilot, maybe a flight attendant. So it's a one-to-many relationship. For each record in the crew table, there's only one employee. But for each employee, they can basically fly on many charters as a crew member. So we've got a one-to-many relationship here. This relationship is untouched. You could get rid of the pilot table if you want to. I wouldn't be disappointed. But there is some information just looking at the table itself that it looks like they're storing information about pilots that they don't store about regular employees. So it might be good to keep that relationship intact. However, the relationship between pilot and charter is now gone. It's captured in this relationship in this associative entity here. All right, so that's it for number 27. Okay. For number 29, 30, and 31, we're going to be using some relational operators to manipulate the view of information. So to do this, I'm actually just going to use Microsoft Excel. I'm going to pull up that one table, the charter table in Microsoft Excel. I got it from the Access database that I uploaded there, so you guys can get to that too. But I don't want to use a database for this right now because I think that using a database might confuse us a little bit because we really haven't gotten into talking about database tools yet. So I'm going to use Microsoft Excel. I think it's a tool that most of us are familiar with, and so hopefully it will kind of make sense here. So I've got the charter table. Go ahead and kind of expand things out so that we can see it better. And I just exported it from the Microsoft Access database. So in here, we've got several fields and some data here. So the first thing says it wants to use the select and project relational operators to return only the char trip, char pilot, and char co-pilot for charters flown by either employees 103 or 105 or employee 109. So first of all of these only ask for char trip, char pilot, and char co-pilot. So I'm just going to get rid of the rest of the columns, and that's using the project relational operator there. So we are using that operator, and we're only selecting these three columns. Okay, so I've used that operator. Now what I want to do is I want to find all of the ones flown by 105 or 109. So I've got a 105 here, got a 109 here, I've got a 105 and a 109 here, 105 here, a 109 here, and a 105 here. Okay, I've also got a 109 here, a 105 here, 105 here. Okay. So the records that have either a 105 or a 109 are this one, these, this one, and this one. So I'm going to take all this, I'm just going to do this manually. Copy this over, stick it right here. Let's get rid of the fill there, expand these out again. And I'm going to get rid of everything that doesn't fit what I'm looking for here. Okay. Okay, now I've got rid of everything that I don't want there. I'm going to kind of just condense these, move these up. Now this takes a lot of time to do this manually, and there's a reason why you wouldn't want to do this, because database tools do this a whole lot better and a whole lot faster, but we haven't got there yet. So I want to show doing this manually because I think it's important to be able to see that, so that when we start using the database tools, we understand the benefits that we're getting there. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 records that have either 105 or 109 flying. Okay, next question says, number 30, it wants us to select only the ones flown by 105 and 109. So here's one that's flown by 105 and 109. And here's one that's flown by 105 and 109. Okay, so again, let's take the whole thing over. Paste it here, get rid of my fill. And I'm going to get rid of everything except for those two records. And move this up here. And there is our answer for number 30. Okay, now 31 wants the difference between this and this. So first of all, to know the difference, I think it helps to know what's the same. So what's the same is these two records here, which is this and this. That means the difference is everything else. So I'll take these, and put them down here, and I take this, put it down here, copy my column headings back over here, and there you go. Now I've got my difference. Okay, again, it's doing it manually isn't probably the most efficient way of doing it. Well, it definitely isn't the most efficient, but I think it helps us to understand what we're actually doing. So, all right. So that's it for chapter 3 homework. That's all we've got. So hope that was useful to you, and I hope this recording worked.